Hello everyone, and welcome to another video brought to you by RouTube. In this video, I will be covering minimal spanning trees and Prim's algorithm, which are in the Year 12 Further Maths module networks. As I do in all of my videos, I will begin by outlining the learning objectives that will be covered in the video. The first objective is to use Prim's algorithm to find the minimal spanning tree, and the second one is, once we have found it, how to actually calculate the weight of the minimal spanning tree. Okay, so before we actually get to an example, I thought what I would do is first list the steps on how to find the minimal spanning tree using Prim's algorithm, which we're going to go through in a second. So like I said, I'm not going to go through each one of these steps, but these are the steps, and feel free to add them to your reference if you like. So yeah, these are the steps that I'm going to go through when we go through the example anyway, but I thought I would list them out for you before we did actually go through the example. All right, let's have a look at the example. So finding the minimal spanning tree. So part A says use Prim's algorithm to find the minimal spanning tree for the graph shown below. And then the second part B, says to calculate the weight of the minimal spanning tree. Okay, so clearly we have to do part A before we can do part B. So following the steps shown to you previously, we're going to start at step 1 clearly, which is to select any vertex. Now it's literally that easy. Okay, you can select any vertex, but what I'm going to do is just going to begin at vertex A just because it's A. Okay, then step 2 says select the edge with the lowest weight connecting to that vertex that you started at. Okay, so clearly we can see here that we have 3 options. Okay, so we have this option here, we have this option here, and this option here. So we can choose either one of those 3. And our job is to select the minimal, or to create or find the minimal spanning tree. So clearly we are going to select the one of those 3 edges with the smallest weight, okay, which in this case was 2. So we're then going to select that one. Then step 3 says 2 vertices are now connected. Look at all the edges coming off either vertex. Okay, so it's really important we essentially start the question again. Select the edge with the lowest weight that connects to either vertex to the tree. Ignore edges which will create duplicate edges, cycles, or loops, okay? So from here, we've got a few different options that we can take. We can go from B to G, we can go from B to C, we can go from A to C, we can go from A to D. Okay, so if we have a look at all those green ones, you should be able to identify that going from B to C is the smallest edge, so therefore that's the one that we are going to select. So therefore from B to C. Then again, we start the question all over again. We continue until all the vertices are connected. So then now, this is an option, this is an option, this is an option, this is an option, and this is an option. Okay, so we've got multiple and heaps of options. So as you proceed through the graph, you're going to see it becomes quite confusing as you proceed. Okay, but it's really important, if you want to use different colors like I'm doing, please just feel free to do so. Okay, if that makes it easier for you. And clearly you should be able to see that the edge from C to E has a weight of 2, so that's the one that we are going to select. Then once again we start again. And now we have from B to G, from E to G, from C to D, and then from E to D. Okay, now we don't have an option to go from A to C because we don't want to use that. We've already gotten to C. Okay, so we're not going to waste multiple edges. Okay, that's not even going to be an option for us. Okay, so now you should hopefully be able to see, and I might just get rid of the other ones, that now we've got 2 edges that we can choose from. Okay, so both of these edges have the same weight of 3, so it doesn't actually matter which one you use. Okay, so let's just go with the one from E to G. Okay, again we're going to start and go from E to G. Okay, now again we're going to go all the way back to the start, and we're going to go. We have all of these options, and you'll see we're going to use that edge that we could have used before, which was the 3 edge from C to D. Okay, so now we're going to use that edge from C to D. And now we've only got one more vertex to join, which is vertex F. So now we've got two options. We can either go from D to F, or we can go from G to F. I might just do that one again. Or we can go from G to F. Okay, and clearly from D to F only takes 5, or the weighting is 5, and then from G to F the weighting is 6. So therefore we're going to use the weighting, or the smaller weighting. So D to F. Okay, now you've connected all of the vertices, so your first job is to redraw the minimal spanning tree on its own. So there we have our minimal spanning tree drawn, which is part A. So then now what we can do is part B. We're now going to calculate the weight of the minimal spanning tree. So what we're going to do, let's just include the weights. So we've got 2, we've then got 3, we've then got 3 here, we've got 2, we've got 3, and then we've got 5. Okay, so we're just going to add up all of those values together, and that is going to give us the actual weight of the minimal spanning tree. So we've then got 2 plus 3 plus 3 again, plus 5 plus 2 plus 3. And therefore we can say that the weight of the minimal spanning tree is 18. So as we normally do, let's put our answer in a sentence. So we can see the weight of the minimal spanning tree is 18. So part A, you actually redrew your minimal spanning tree on its own, and then part B, you calculated the weight of that minimal spanning tree. Thanks so much once again for everybody that's watching and listening to this video. Hopefully you learned a thing or two about minimal spanning trees and Prim's algorithm. If you did, feel free to like and subscribe to the channel and the video. Once again, thank you so much, and I look forward to uploading some more videos for you all.